in the next section, I'm going to talk about a few modifications to this rule of 10. As I mentioned earlier in the lecture, vapor pressure changes with temperature. And more precisely, the vapor pressure increases with the temperature of the liquid rather than ambient temperature. And so the vapor pressure at temperatures other than ambient, which is taken to be 25 degrees Celsius, can be found in several different ways. You can look up a standard physical chemistry textbook, or you can use certain equations called Antoine's equation or the Clausius-Clapeyron equation. And these are also going to be in an Excel spreadsheet that I will provide for the course materials. And the third way is to use it with a rule of thumb, which I'll talk about in a second. So if we want to be physical chemists and we want to be very precise, we can find out the vapor pressure using Antoine's equation that is shown here, where the log of the vapor pressure is equal to a constant A minus another constant B divided by the temperature plus another constant C. And the temperature is in degrees Celsius. And the A, B, and C parameters are constants that are unique to each chemical. Another equation to predict the vapor pressure at different temperature is the Clausius-Clapeyron equation. The Clausius-Clapeyron equation is the log of the vapor pressure versus 1 over T, where the T is the temperature in absolute degrees Kelvin. And so the slope of this straight line is given by m, and c is the intercept with the y-axis. And at the boiling point, the vapor pressure is 760 millimeters of mercury. And so if the vapor pressure of one more point is known, the vapor pressure at any temperature can be calculated. And these equations are also discussed in Chapter 25 of a strategy for assessing and managing occupational exposures, which is the AIHA monograph on exposure assessment. How do we use a rule of thumb instead of these more sort of involved equations? The rule of thumb is this: the vapor pressure of the chemical will approximately double with each 10 degree centigrade increase in the temperature of the liquid. So for example, if the vapor pressure of a chemical is 25 millimeters of mercury at 25 degrees centigrade, its vapor pressure at 35 degrees will be roughly 50 millimeters of mercury. And at 45 degrees will be roughly 100 millimeters of mercury. And as you can see, this is a very easy to use rule. You typically always know what the vapor pressure of the chemical is at 25 degrees centigrade. And for many chemicals, these are also in your Excel spreadsheet. And so if you now have to use this rule of thumb at a different temperature, you can just use this doubling rule.